two metric spaces. So let's say x and y are metric. And let's allow ourselves, we may be interested in functions that are only defined on a subset of the domain. So I'll take E in x. I'll require P to be a limit point of big E. And let's let ourselves be talking about a function from E into Y. Okay. So the picture that I want to draw here is something like the following. Here's the space x. Here's the space y. And I'm only interested, perhaps, in some subset of the domain and a function from this subset of the domain into y, perhaps. This is my set E. And I'm going to be picking P, a point that is a limit point of E. So it should be possible to converge or get closer and closer to P in E. Okay? Okay. And now I'm asking, does a particular limit exist? What do you think that means intuitively from this picture? Or even this picture. What do you think that means? So I have a mapping down here. I have a graph upstairs. What would you like to be true up here? Yes, Paul?
So if we have some image of P's, call it Q and Y, then all of the points that are getting closer and closer to P in X, the images of those should also be getting closer and closer to Q.
Okay, so yeah, so we're going to say this thing has a limit, and we'll call that limit Q if whenever you want to say if you have a bunch of points that sort of that get closer and closer to P here, or whenever points get closer and closer to P, a bunch of points get closer and closer to Q over here. They're images, right? That's sort of the idea, okay? Now, the way you've described this, you've sort of described this in terms of maybe a sequence of points. That's actually one way to describe this limit, but I'm going to first do it just in terms of distances, okay? So we're going to develop a criterion that looks something like convergence criterion for sequences. Yes?
Do we want P to be a limit point of E and in P?
Not necessarily in E, yes. P does not necessarily have to be in E. I'll do an example later. But you could imagine, for instance, P being on the boundary here, okay? And Q, well, there's no relationship between P and Q necessarily, other than the fact that as you get closer to P here, you should get closer to Q here. Okay? We're not requiring Q to be the image of P. Okay? Well, I'll do some examples there as well. So, for instance, up here, well, I can just do that here. Well, I'll just do some examples after I make the definition. So let's write this down. So what does it mean? So to say, okay, well, we could write this two different ways. We could say f of x arrow q as x arrow p. Or we could say it a different way. We could say the limit as x goes to p of f of x is q. So these are two different ways of saying the same thing. To say this means what? Well, first of all, it means that there is a q. There is a q that satisfies this notion. So there is a q in y such that, okay, help.
Like if you have any neighborhood around Q.
Good. For every epsilon bigger than 0, and that epsilon will be an epsilon ball around Q. So here's an epsilon ball around Q.
So for every one of those neighborhoods, you can pick a corresponding neighborhood in X around P.
Okay.
The image of all the things in that neighborhood maps to the epsilon ball.
Okay. Yeah, so before, when we talked about convergence of sequences, we said for any epsilon, there's a point in the sequence beyond which you're close enough. Here we're going to say, for any epsilon, there's a radius around P in which if you're close here, you're close here. Okay? And so this radius we'll call as delta. And I want you to notice this is a delta ball. It is the delta ball that's in E. Okay? Okay, so here's the important part. For every epsilon bigger than 0, there exists a delta bigger than 0, such that what? Well, whenever you're close enough in delta, for all x and e, 0 less than delta, the distance between x and p less than delta, implies that the distance between f of x and q is less than epsilon. Okay, now there's some curious things about this that you're probably noticing. One is, what do I mean by d? D of blah blah. That's the metric. Where? In x. What about this d? It's a metric in y. I'm not writing metric in x and metric in y, but you could think of it if you want. This is really a metric in those two spaces. Okay, whatever they are. If it were the real numbers, that metric would be absolute value. Okay? Yes. Good question, because so we'll want to deal with situations where the function's only defined on a subset. You know, like you might have the real numbers, but you might have a sequence that's defined only on the integers, right? Or something like that. Okay. Okay, the other thing that's kind of curious is I've said not everything, I'm not looking at all points in the ball. There's one point that I'm not allowing myself to say anything about, and that is if x equals p. So we don't, basically, this condition excludes x equals p. So we can allow p, the image of p, to be doing whatever it darn well wants to do. Okay? But this is the definition of convergence of the limit of functions that you should memorize. Okay, the fact that there exists a q is kind of that's where you start off. But often you have a q and you're just trying to decide, does this limit approach q? Well, it does if this condition holds. If for any epsilon you can get close enough in the domain such that the images are close enough in the codomain. Okay. So let's do some examples here. Here's a classic example, which you think of when you think about limits where p is doing whatever it darn well pleases with the function's doing whatever it pleases at p. We don't really care what's happening at p. To say that the limit exists just means as long as x is going to p, f of x is going to q. That's the idea. That's what it means to say the limit exists. Now, of course, x should converge to, this condition should hold from both sides, yes? So that if you approach from this side, well, then you'll approach from above as well, right? Okay, this is the graph picture, okay? This is the mapping picture. Yes, Jenny? Does E have to contain every point in X where F is defined? Yes. Okay. F is defined as a function from E. Okay. But that's true. Okay. That's true. Oh, excellent question. Yeah, so your worry is that this function is doing different things at different places. Yes,